So welcome all. Today we'll start to our extra session NPTEL Fluid Mechanics PMRF live TA session. So I'm Om Prakash Maurya from IIT Guwahati. So no one joined till now, so I'm going to record the video. So please you can access through YouTube channel. So now we'll start question number 1. The question 1 is, what is the correct expression for hydrostatic pressure at a point within a fluid at rest? The fluid density rho, gravitational acceleration z, and depth h. So option A is P is equal to rho gh, P is equal to rho by g into h, P is equal to rho by g by rho into h, and option D P by. As you can see here, the correct answer is A. Let me discuss a little bit more about the hydrostatic. So here is the meaning of hydrostatic. Let me okay. So let us suppose here you can think this is a pond. You can think this is a pond. Now I want to measure the pressure at the bottom. Pressure at the bottom, and the depth of the pond is, let us suppose, 2 meter from the water level. So if anything is here, how much pressure on that? So how you will measure, or how the pressure variation, how pressure will vary? So as you know, the pressure is rho Gs. So with respect to pressure is a linear. G is constant, rho is constant because it's water. So linear variation with H. So means like that your pressure will be vary. Always remember please. And this here also every here. This is amount is rho gh. Always remember this concept will also use in your further courses like soil mechanics. So always remember this is the important concept from the hydrostatic. Now the next question is, what is the condition for fluid static to be applied in a system? We are talking about here the fluid static. Option A, the fluid must be incompressible. Option B, the fluid must be moving at a constant velocity. Option C, the fluid must be inviscid. Option D, the fluid must be at rest or moving with a constant velocity. So here is the meaning is, fluid must be incompressible means constant. Your density should be constant. So is it related with the fluid static? No. The fluid must be moving at a constant velocity. Yes, we can consider these things because yes, acceleration is zero. If acceleration is zero, definitely it will look like the that is, we can consider these things. Now the next option, the fluid must be inviscid means dynamic viscosity zero. Is it the condition for fluid static? No. Option D, the fluid must be at rest, okay, or moving with a constant velocity. Means here velocity should be zero or the acceleration zero. Here two condition is given. Yes, we can go with that option, option number D. Now the next question is, what is the name of device used to measure fluid pressure in a system? Let us suppose a system is there and here we want to measure pressure. Used to measure the fluid pressure in a system, whether it is barometer, manometer, hydrometer, or the thermometer. So definitely you know already, we'll use the manometer for measuring the pressure. This is the very important. Or you can pause the video after my reading the questions. You just pause the video, look very carefully all the options, then you try to give your answer, then you can start. Or I can wait 1 minute, so that will be better for you. You can think on that also. You will feel like you are in the live class. Now we'll move on the next question. Next question is, what does Pascal's law? Here I will wait 1 minute. So what does Pascal's law state in fluid mechanics? We are here talking about the Pascal's law. Option A, the pressure increase with depth in a fluid at rest. Option B, the pressure remain constant in a fluid at rest. Option C, the pressure is inversely proportional to velocity in a fluid flow. Option D, the pressure applied to a confined fluid is transmitted undiminished to every point within within the fluid. So here I will wait 1 minute. So please just think on that. So just you will feel like you are in the live class, like the previous class. I think today no one joined. Still no one joined. Let me just check. Okay, no one joined still. Okay, I will be online during the 6 to 8 2 hour. If anyone join, that will be fine. Otherwise, I'll just teach like that. So we are talking about here the Pascal law. So let me just draw the, if this is a fluid body. So here, let us suppose we are talking about this particle. So here you just think on, as per the Pascal law, the pressure on that fluid element, or that the group of fluid element, will be transmitted undiminished, here you can say the equally, at every point within the fluid. So option D will be correct for question number. That is this question, for this question. Here is the no question number. Now the next question is, here is a question. Okay, let me just explain for you. What is the principle of buoyancy in fluid mechanics? Principle of buoyancy we are talking about here. This is very important concept of buoyancy. This is having the historical point, that is the historical connection with the, that is the king, and king and some, you can say the some person in the kingdom. So just you can search, you will find out. Now the option A here is, what is the principle of buoyancy? That is that person is Archimedes, no, none other than Archimedes. The object submerged in a fluid experiences an upward force equal to weight of the fluid displaced. Option B, the object submerged in a fluid experiences a downward force equal to weight of the fluid displaced. Option C, the object submerged in a fluid experiences a force proportional to depth of submergence. Option D, the object submerged in a fluid experiences a force proportional to density of the fluid. So Here just answer is visible to all of you. Option A is correct, but just try to think on each point, that is the each option. So here is option A is correct. Means object submerged in a fluid experiences an upward force equal to the, that is equal to weight of the fluid displaced. Means what is the meaning? Let us suppose an water body, and in the water body you just put one log or something like that, or you can say any body, you just put it like that. So half portion of the body is submerged and half just above the top of the your water surface, like that. Here is a V by 2 volume, half volume, here is a half volume, right? So upward force, that is the this upward force, let me write like that, F up will equal to of what? The weight of fluid displaced, that is this much weight. How much weight will be displaced? This this volume will be displaced, only this, not above one. So weight of fluid displaced. How you will calculate? Because rho of the body, you know already the density of, what is the density? Mass into acceleration. Oh, what is the density? Mass by volume, you know already. Or what is the unit weight? Unit weight is nothing but weight by volume. So if you want to calculate the weight, or how you will calculate the unit, rho into z. So you can go with that also, though, because of the g is constant for all. So now I will put it here, gamma into volume. So this is the above. Gamma of what? Whatever the solid you have put it. And the volume of, that is you can write here the gamma solid into V by 2. Because the volume, half volume is this side. So hope you get the understanding about your buoyancy. Now we'll move on the next question. Next question is, what is the name of phenomena? Let me just, okay. What is the name of phenomenon where fluid flow is smoothly in parallel layer with the minimal disruption between layer? Just please think on that. 1 minute, after 1 minute I'll just, anyone joined till now? Okay, still I think no one joined. Yes. So here is option: turbulent flow, laminar flow, transitional flow, or the viscous flow. We are talking about here the parallel layer, smoothly parallel layer. So I think we have spent 12 week, or you can say the 24 hours. So it is very easy to give the answer for all students. So such type of flow is known as, if water is flowing like that, is laminar. Remember please, option B will be correct for this. Now we'll move on the next question. And how we will quantify here is the various beautiful number, Reynolds number. Rho V hydraulic diameter. Remember please, rho V D here is the hydraulic diameter. And hydraulic diameter is nothing but 4 AC by area of cross section divided by P. For circular, if you want to calculate, if the diameter is D, how we will calculate? 4 into area, pi by 4 into D square. For if flow is full, pressurized flow, pi by 4 into D square divided by perimeter, that is pi D. dd will be cancel out and 4 will be cancel out. So dh. So hydraulic mean depth or hydraulic mean depth is equal to diameter of circular. So remember please, for circular pipe your Reynolds number is rho v d, that is the diameter of pipe mu. If your pipe is rectangular type, remember please, if pressurized flow in the rectangular channel, so if I assume this is B and this is your depth Y, so here area is B into Y. So what is the DH? DH here 4 into BY, and what is the perimeter? B, this is B also, this is Y also. So 2B plus 2Y. So you can say here B 2by divided by b plus y. So this is the whole area of cross section. So remember please. So what is the Reynolds number for this case? Reynolds number is nothing but rho v, that is the velocity, average velocity we are talking about. Remember, here is the average velocity, and dh is, oh, this is dh, not dc, this is dh. So 2by divided by b plus y. This is dh divided by mu. That is the dynamic viscosity. Remember please. So like that we'll calculate for uh, your hydraulic mean depth. Remember. But for open channel, remember please, your formula will be changed. Here we will use the hydraulic radius. Remember please, in case of open channel, we use the hydraulic radius at the place of hydraulic diameter. Remember always RH. RH is nothing but A by weighted area by weighted perimeter. Should be remember. This is the concept. Now we'll move on the next question. So this is the very important things. Now the next question is, what is the Reynolds number used for fluid mechanics? Used for used in fluid mechanics. So to measure the pressure gradient in fluid, whether Reynolds number do these things. To determine the velocity profile in the fluid flow. Option C, to predict whether flow is laminar or turbulent. To calculate hydraulic radius of the channel. Just please think on that. In the previous question, I have given you a hint. If you are able to give the answer, definitely you are know about something, the laminar flow, turbulent flow, or fluid mechanics, you can say, at undergraduate level. So please try to give your answer. So still no one join. Okay. Okay, let me move ahead. So Reynolds number here is we use generally for laminar and to predict the laminar and the turbulent flow. For example, I have shown you one example in the class, that is one flame like that, and the smoke of the flame is like that parallel very near, then after little bit like that, and then after very zigzag like that. Water is like that, is your flame is like that. So this portion is if parallel or smooth laminar, this portion is transition, and this portion is turbulent. So like that I have shown you in the previous classes. So now we'll move on the next question. Next question is, here is very interesting thing. Your Reynolds number is the ratio of inertial force divided by viscous force. Remember please, inertial force divided by viscous force. Next question is, which one of the following is a correct expression for velocity profile in laminar through a circular pipe? Please, I need answer from your side. So just if you just please think on that all options. I'll just tell you after 1 minute. Please think on that. So here let me just discuss you on a parabolic, whether it will be parabolic, laminar, exponential, and the irregular. Which type of velocity profile look like in a circular pipe flow? Let me just give you example. For a circular pipe, I have explained in the earlier classes. So I'll discuss here the fully developed concept also. So in a pipe flow, let us water flowing in this direction. So now initially your velocity diagram will be like that. Here is the straight. Now little bit up. Now little bit this much. After that, it will be completely parabolic. So like that. We can see here from this side also similar kind of thing. Here is a parabolic. After that, your velocity diagram will not change. Here is a changing pattern. Just you can see here. Up to that parallel, then a straight line. That is parabolic, a straight line. Here is the parabolic. This much a straight line. This much a straight line. But up to that length, this no length is known as your development length. Development length. Remember, please. This length is known as development length, and the diagram is like that. This is a velocity diagram. After that, your velocity diagram will not change. Parabolic distribution. For laminar flow, this development length, I have tell you already. You can write. I'll not write here. And for laminar and for turbulent, also I have just tell you length of development for turbulent flow. You can see before giving the final exam, you can go through that also. All concept you please go through. Now we'll move ahead with the next question. Next question is, what is the correct equation for Bernoulli's principle in fluid mechanics, neglecting viscous effect and external force? So this is a very famous principle in fluid mechanics at undergraduate level. After that, the Navier-Stokes equation is very famous for CFD modeling and all. So up to that undergraduate level, your Bernoulli's equation or Bernoulli's principle is very famous. Lot of question you can see in your GATE exam also, and other as well as in state exam also. That is what is the principle of, whether it is work on conservation of mass, energy or momentum. So all these things I'll discuss in this question. So please just you try to brush up your mind and think on that. What kind of questions, what are the assumption behind the Bernoulli's equation? All these things I'll discuss here. So please, before discussing me, you just think on that. You can write in your copy itself. So definitely you will feel something when I will explain. Definitely you will feel uh, the I mean, definitely you will feel like everything you know previously. So within one explanation, you will just catch up. So please think on that and try to write the questions. Try to write all the Bernoulli's principle assumptions and formulas and all. So okay. So one student is joined here. So let me just ask whether I am audible. Vijay Kumar, I am audible or not? Okay. Thank you. So I have just solved lots of questions. So please, if you are, the question is visible, Bernoulli's equation. Okay. So please, if you can give the answer, which option will be correct for the Bernoulli's equation here? So today is the last class. So today is a 2 hour extra session class. So we have already completed the 12 week, and this is the 13-day class. So after that, there is no TA session for fluid mechanics for this year 2024. So please, in the chat box, you can write your answer. So as we know, the Bernoulli's equation is a very famous equation in fluid mechanics at undergraduate level. So we know already in this form, P by rho z plus V square by 2z plus Z is equal to constant, or C I'll write here. So if I write in this form, that is I free the P thing. So this is constant, this value is constant. So I'll multiply, that is the every places. So P divided by rho z into rho g plus, in each term I'll just multiply. So here is rho z plus z into rho z. This side also there is no change after multiplying if I multiply both sides. So again this will be converted in the constant C1 you can write here. So this will be your rho gz. Here is h. You can think on. I am writing the at the place of h z here. Now this is gg will be cancel out. So you can write v square by rho v square by 2. Here is only p because this will be cancel out. So if expression like that, p rho v square by 2, yes, rho gh. P rho v square by 2, not. This is not. This will also wrong. This will also wrong. So we can go with that. Option A will be correct. Yes. Now the next question is, next question here. What is the equation of motion? Equation of motion for inviscid fluid, expressing the conservation of momentum. So option A is Euler equation. Option B Navier-Stokes equation. Option C Bernoulli's equation. Option D continuity equation. So please try to give your answer in the chat box. Which option will be correct? So I'll wait 1 minute. Please try to give your answer in the chat box. The equation of motion for inviscid fluid we are talking about here. So the answer of this question is, let me just discuss. So we are talking about here the inviscid fluid, means the fluid dynamic viscosity is zero, means there is no shear stress component in the momentum equation. So Navier-Stokes equation we can cancel out. There is continuity equation. Definitely this is based on the conservation of mass. We are talking about here the momentum, and whether it will be Bernoulli's and Euler. So definitely we will go through the Euler equation. So Euler equation is very useful for writing the equation. This is the actually this is a form of the equation of motion for inviscid fluid based on the conservation of momentum. So now we'll move, but remember please, the criteria is here, the dynamic viscosity of fluid is zero, then we can apply the Euler equation. Otherwise we'll go, let me just come on the next question, then we'll discuss about the viscous fluid, about the viscous fluid. What is the correct form of Navier-Stokes equation for an incompressible fluid? We are interested, I am interested here to know from your side the Navier-Stokes equation for an incompressible fluid in the correct form. So please just think on that. You can write your answer in the chat box. Okay, the correct answer here is, for this question, the correct expression for the Navier-Stokes equation is, if you will see here, in Navier-Stokes equation we consider body force plus your pressure force plus your shear stress force. All three component in this question, in this option only. Just if you will see here, and this side is your acceleration part. So we know already the force is equal to mass into acceleration. This side is force, and if you that is rho this side, so you can say here the this side only, the your mass component, that is the acceleration component, is this side, and the force component this side. So you can go through the option number 1 here, option number A. So Navier-Stokes equation is like that. Now we'll move next question. This is the viscous term, remember please, that is the mu del square by V. This is the viscous term. Now we'll move, what is the correct form of the continuity equation for an incompressible fluid? Correct form of continuity equation for an incompressible fluid. These two terms please think. And then the first option is rho del rho by del T plus the divergence of rho v, here is the divergence of velocity is equal to 0. Now just you can think this is the your Navier-Stokes equation, and this is the again the divergence of rho v. So here we are talking about continuity equation for incompressible fluid. So just think on that. Only assumption here is incompressible. So please you can write your answer. Otherwise I'll tell within 1 minute. Okay, the correct answer is here. Let me just. What is the correct form of continuity equation? So as we know a little bit discuss, I want to more here. So it is based on the conservation of mass. Conservation of mass. So we are talking about incompressible fluid means rho is constant. But this formula is, here is the two thing. One is, if we take assumption only incompressible, and if I take the assumption incompressible plus steady, both means change with respect to time will be 0. If these things and rho is constant, so this expression will be your correct for these two for these two assumption, incompressible and steady. But here is only your assumption is incompressible, that is rho is constant only, so this expression will be valid here. So option A will be correct for this. It will be incompressible, it may be unsteady, steady, there is no matter, but here only assumption is incompressible, that's why we'll go through the option number A. Now the next question is, what is the correct expression for dynamic viscosity mu in the Navier-Stokes equation. What is the correct expression for dynamic viscosity mu in the Navier-Stokes equation? Whatever we have just seen above, the Navier-Stokes equation, like if I write here, just I want to show you these things. Del V by del T plus velocity into this minus equal to 1 by rho del P plus mu del square velocity plus g. If it is like that, so what is the expression for mu? Okay, yeah. So please just think on this question. What should be the value of mu here? Whether A option mu is equal to rho VL by RE, mu is equal to rho L square by V RE, mu is equal to rho VL square by RE, mu is equal to rho V square L by RE. Which option will be correct for this? Just think on that and try to give your answer. Now let me write here your expression. Hope I am correct. We write this side. Okay, so here is the correct expression for option number C. The mu is equal to rho VL square by RE. Remember please, option number C will be correct here. Rho VL square by RE. Now the next question is, what is the correct form of Bernoulli's equation for an ideal incompressible fluid? Remember please, here we are talking about ideal incompressible fluid. So just think on that. What is the correct expression for the Bernoulli's equation? So let me just show you the answer. So answer of this question is B. Remember, for ideal and incompressible fluid. That is here the explanation is Bernoulli's equation for ideal incompressible fluid state, that the sum of kinetic energy per unit volume, potential energy per unit volume, and the pressure is constant along the streamline. Okay. Okay. I think this equation should also be correct because we have considered. Okay, I think this question is having some mistake in the option formulation. So because of the after assuming all these things, that is incompressible fluid and all, we derive these things P by rho z plus V square by 2z plus Z is equal to constant. There is no rho term here. So I think this is the I think mistake. Option C should be correct here. Okay. So please you can go through some standard notes so you can follow with the this question. You just see whether which option is correct and wrong. Okay, let's see. The next question is what is the correct expression for Reynolds number Re in fluid mechanics involving characteristics length L and velocity V and the dynamic viscosity is mu. I have just already told you Reynolds number formula rho VL characteristics length by mu. Previously I have just told you rho V dH, that is hydraulic diameter by mu. So this L is connect with these things only. Hydraulic diameter is nothing but 4AC by P. Just I have told you previously, but for just sake of time, for sake of understanding for this time only, if the circular thing, the diameter is circular pipe and diameter is small d, area, that is area of cross section will be pi by 4 into d square and perimeter will be pi d. So if you will put here 4 into pi by 4 into d square divided by pi d, so d will be cancel out and pi will be cancel out, only d will be remain. So your dh will be, that is hydraulic diameter will be equal to small d, that is the diameter of the pipe. So for circular pipe your formula rho v small dy, that is your diameter, small d or capital D, whatever you can write here, that is mu. But you should know what is the meaning of this d. So d is the diameter of pipe. For rectangular channel similarly you can find out. For rectangular channel b here and y here, so a is equal to nothing but b into y, but for perimeter is 2b plus y. So similarly your dh will be 4 into b into y divided by 2by, and you can write here at the place of dh, that formula will be your Reynolds number for in case of your water is, that is the pressurized flow in rectangular channel. Now we'll move ahead on the next question. I have explained in the earlier questions, so please you can go through the video for very carefully. I have just told, just for sake of your understanding I have just told you. Now the next question is what is the correct expression for Darcy's-Weisbach equation describing pressure loss in laminar flow through a pipe? Del P is equal to F, that is the friction factor, L by D rho V square by 2. Option B, del P is equal to F L D by rho V square by 2. Okay. Option D, I think all options are same. Because here rho v square by 2, rho v square by 2, FLD. Okay, all three option is same here. Okay, so we are talking about here the pressure loss. So please think on that and you can just write in the chat box whether which option A, B, C is the same option you can think, and D which option will be correct. Or let me just show you the answer for this question. So your change in P is equal to nothing but FL D by V rho V square by 2. Remember please. That is the change in pressure. Now we'll move on the next question. Next question is, what is the correct expression for the Hazen-Pauli equation describing the laminar flow through pipe? So here is the option. Okay, I just think on that. So option A, B, C, D. You just please try to give your answer. Which option is correct for A, B, C, D? Which option? After this question, I'll take a 5-minute break. Then I'll come back. So please you can give the answer of first. Then after I'll show you. This is only formula about the Hazen-Pauli. So let me just show you the answer. So answer of this question is A, that is discharge is equal to pi d4 divided by 128 mu del P by L. So remember please. Now next question I'll show you. If you want to solve, you can solve. Otherwise, I'll show you the answer after 5 minutes. So the question is, what is the correct expression? Let me go on the question. What is the correct expression for the drag force Fg acting on a sphere in a fluid flow given the fluid density rho, a sphere radius r, and the velocity v, and the drag coefficient cd? So question is asking about your drag force. What will be the drag force? So which option will be correct for this question? A, B, C, D, which option? Please just try to give your answer. Or let me just explain. So FD is nothing but half CD rho A V square. So here is velocity, this is average velocity and average velocity, and the drag coefficient is always given, CD. Rho is also given. Here the radius. So area of your sphere, if this is a sphere, if I just may, what will be the area? Please just think on that. Then very easily you can give the answer. This will be the area of a sphere. Here is 4 pi r square. See, if I put here, that is the surface area. So the expression I think will be changed. Rho CD, rho area, if I put here 4 pi r square into v square. So here the expression will be like that. But if I okay, the options should be modified. I think the 2CD rho pi r square v square. I think this should be the answer. But why the option A is given? Drag force acting on the sphere in the fluid flow is given by this, where rho is the density and r is the radius of a sphere, v is the velocity, and cd is the drag coefficient. Whether it is taking the half surface, if we take the half surface, then if this surface is exposed to the drag, then definitely again it will be the not any option is matching. So I think these options are wrong. So we'll move on the next question. Next question is, what is the correct expression for pressure distribution in a fluid at rest in terms of fluid density, rho, gravitational acceleration g, and depth z? So please just try to give your answer. I'll wait 1 2 3 minutes. So the correct expression is here. If just for example, I want to explain here. If here is a pressure is atmospheric pressure, you can say the P naught, and you want to calculate the pressure at that level, jet. So what is the pressure at the level of jet? Initial pressure plus the variation is rho gh. So like that. If we want to calculate the absolute, this is, if we want to calculate the gauge, only rho gh. So now we'll move with the next question. So option A will be correct here. Next question is very, very important. So, okay. The question is, the fluid flowing in a figure 1.3, here you can see, this is figure, has an absolute viscosity mu is equal to 0.0010 lb. So we'll not confuse here with the unit system. Next question, next next, and a specific gravity is given 0.913. Calculate the velocity gradient and intensity of the shear stress at the boundary and at point 123. So here you need to calculate the velocity gradient du by dy, then shear stress tau at boundaries at 1, at level of 2, at level of 3, 3 inch from the boundary, 3 inch from the boundary, like from here. If this is 1, this is 2, this is 3. So from here you need to calculate tau 1, tau 2, tau 3. Now, assuming, what the assumption? A straight line velocity distribution. Here you need to assume first the velocity distribution is like that. This is the first assumption. In first case you need to calculate all these things. Of the assumption number B, a parabolic velocity distribution. You need to understand, here is the wall, here is the, you need to consider parabolic. This is parabolic. For this you need to also calculate all these things. The parabola in the sketch, here is the one thing is given. In the parabola in the sketch has its vertex at A. Here is the vertex, and origin at B. This is the origin. So this is a very important question. So please, I'll give you 10 minutes for this. So please just try to calculate all these things. Then after I'll explain this question in very detail. So I'll explain this question is with very fundamental of the parabolic equation and all. First part is very easy because in the first part is linear thing is given. The velocity varying is linearly. So you can very easily calculate the all these things, that is your dynamic viscosity. Dynamic viscosity already given, the velocity gradient and your shear stress. But in the second part, the parabolic part, it is little bit difficult if you don't know the equation, what is the basic equation of parabolic. So it is very difficult to solve. So that thing I'll explain today, or maybe this is the last question for today. I have lots of questions. I'll share everything in the Google Drive. You can go through one by one. So so just I'm waiting for your answer for first part, because first part is very easy. If you are able to give the answer, please write in the box. Okay, let me discuss. So in first part, I'll consider only the linear thing. The velocity is varying linearly. These things only. So if this is y-axis and this is your x-axis, x-axis is equal to u, because this is the velocity axis. So you can say the axis is u and this is y. Okay. So here is the 3 inches given, and this is 45 is given. So just for your sake of understanding how velocity is changing from this to this, what is the actual velocity gradient? Velocity gradient, if it is linear, du by dy, you know from your basic fundamental of del v by del y. So here del v is 0 to 45, 0 to 3, so means 15. Del u by del y is 15. Whatever the unit, let's say 15 unit I'll write here. You just go through what is the unit, you can calculate. So this is a 15. The first, I am solving the case number A. Now what is the tau? So you know already, tau is nothing but from the Newton's law of viscosity, del u by del y. So already you, for each and every point, for here your velocity gradient will be 15, here also 15, because there is no change in the line. Here 15, here 15, everywhere 15. So tau, boundary, and 1, 2, 3 everywhere will be constant. So remember please. So what is mu? Mu is 0.0010 into 15. So if you will calculate 0.015 LV by feet square, that is your tau. Similarly at y1, at y2, that is tau 1, because everywhere your mu is constant and this thing is also constant. So everywhere it will be same. Everywhere will be same. So remember please. So now we'll move on the next part, that is the B part. So first of all we need to calculate for B part also du by dy. How will calculate du by dy? First of all we need the expression for u. That is u means x-axis. First of all we need the expression for x-axis. X-axis in terms of function of y. So how we will calculate? For that we need expression. So I have the parabola formulas all. So actually we have the four type of parabolas like that. So our case is this, because our case is like that. If I complete all the, it will go like that. Already in the question is given this is a vertex and this is origin. Origin means your, if this is x-axis, this is y-axis, and this vertex is h comma k, and this is origin. Origin here 0 comma 0, because y is 0 here and x is also 0. So but in our case x is equal to u. So if I fit here x is equal to u, what the value of a? I'll calculate. And what is the value of y? Y here is y, because y is the same axis. What is the value of k? What is the k here? K here is 3. And what is h? H is 45. This direction, x direction. So this is 45 square plus k here is 3, not 45. This is 3. Or let me take for clear understanding, because this is a very important question. Here is 3 square plus 45. Now the equation is u is equal to a y minus 3 square plus 45. But what is the value of a? Now we need to know at any point. Here we need to know u value and y value. Then we'll put here u and y value, because here 2 is 2 unknown. So if I put here the 2 unknown, then we can easily find out at any point if we know. So here we know already. What we know? The u and v is equal to 0. So let us put here. So if you will put, so it will come 0 is equal to a, and v means here y I am writing 0 minus 3 square plus 45. So a is equal to minus 45 divided by 3. Minus 3 square means 9 here, so you can say 5 minus 5. This is the 9. Just for clarity, let me. Okay, so now I can write the final equation here. U is equal to 45 minus a means here is a plus 5, but a is minus 5, so I'll write here minus 5 45 this, and a is minus 5, y minus 3 square. Now we can very easily calculate du by dy. 45 minus du by dy is equal to 45 is constant, that's why it will be 0. This is 5 into 2y minus 3. Again, the differentiation of y minus 3 is y 1. So du by dy is equal to minus 5 y minus 3. Now, what is the value of du by dy at y equal to 0? It will be minus 5 into minus 0 minus 3, so it will become 15. What is the value of, one thing you can remember, here is also 15. You can just think at the 0 level. At the 0 level both values should be same. For mathematically also we can see here same, but the things will be changed if I go du, here is a u, du by dy at the level of y is equal to 1 inch. So it will be minus 5 into, here I think not visible, so let me write another place. So I have the very clearly for you how we'll calculate a and all. So here we have calculated these things. The example on board I have written. So here I want to write the expression for du by dy at 1. So minus 5 into y, that is 1 minus 3. So here minus 5 into minus 2, it will be 10 unit. Whatever the unit you can calculate, the velocity unit divided by length unit. So here also, that is your feet by second divided by feet. So that is the second inverse you can write here. So whatever unit you can think on that. So okay, so 10 unit at the level of du by dy at the level of your y is equal to 2. Again the game will, that is the, your expression will be changed. Minus 5 into 2 minus 3. So minus 5 into minus 1, it will be 5. Again du by dy at the label of y is equal to 3. So it will be minus 5 into 3 minus 3 will be 0. Remember please. So it will be 0. So now if I try to calculate tau 1, tau 0, tau 1, tau 2 and tau 3, what will be the expression? That is mu into del u by, mu is constant for all, so I'll write the answer in terms of mu, del y, here also mu, del u by del y, mu, del u by del y, mu, del u by del y. Okay, so this is the 0 second inverse, the unit is second inverse. So here is a 15 mu into at the level of 0 at y is equal to 0, your at y equal to 0 15 second inverse. So you can write 15 mu. 15 mu. This is mu into at the level of 1 is 10. So you can write 10 mu. Now for 2, mu into 5, so you can write 5 mu. For this, mu into 0, it will be 0. So remember please how we'll calculate such type of questions, such type of problems. Always remember. Okay. Oh, here I think I have done one mistake, big mistake. So what is the mistake? Mistake is if I will write the differentiation, I will write the differentiation. So here 5 is there and here it will become again 2. So it will be 10 here. Here the value will be 10. So you need to multiply all this value by 10. Here is 10. So 3 into 10 is 30. So this will be 30. Okay, still very simple mistake, very small mistake. So 30, here is 10 again. So this will be 10, that is 20. Here again 10, and this will be your okay, let me write very clearly because it might be some confusing for anyone. So hope you people got I think only one in join, so hope you got it. So but let me just write very clearly for other. Okay. So if we calculate du by dy here, du by dy, it will be 0 minus 5 into 2 into y minus 3 into 1. So it will be minus 10 y minus 3. So du by dy at label of y equal to 0, it will be minus 10 into y minus 3, y will be 0. So it will be minus 10 into 0 minus 3. So here you can just think on 30. Second inverse. So whether, yes, second inverse. But previously at the level of 0 your value was 15, but here is 30. So please, previously just I was thinking at the origin the value should be same for velocity or the expression velocity gradient, but this is not like that because the graph is changed. Definitely these things will be changed. I think you got it, my point. Now the question, now the du by dy at label of y is equal to 1. So here is minus 10 into y minus 3. So minus 10 into y value is 1 minus 3. So minus 2, it will be 20 second inverse. Now du by dy at y is equal to 2. So it will become around minus 10 into 2 minus 3. So it will become minus 10 at y is equal to, that is the del u by del y as y is equal to 3, it will be minus 10 into 3 minus 3 will be 0. So hope you got it. Tau 0, tau 1, tau 2 and tau 3. So if I write in terms of mu into velocity gradient at the level of 0, so it will be 30 mu. This will be your mu into at 1, it is coming around 20. So it is 20 mu. And similarly, mu into at the level of 2, it is coming, this is a plus 10 because minus 1 and 10, so 10 mu. And here is mu into 0, so it will be 0. So hope you got it. So overall, here is the key thing is how to calculate the expression for this parabola. In the question is already given, the parabola vertices is at that location. That's why we have considered the k, h and k value. And here is the origin, so that's why your v, because here x is equal to nothing but x is equal to v. So here if I try to show you in the board, here I have very clearly written a is minus 5, which we have calculated using this. First of all, we try to calculate the expression, then after we'll put the origin value and find out the a value. Okay, so here is x is equal to u. At x-axis is u. That's why at the place of x we put u. Here is y. At the place of y we have y. There is no issue. And what is k and what is h, you know already. That is these things. That is the vertices. So overall these things for today. So we have lots of questions like that also. So please you go through one by one. Just I'll read the question, I'll give you hint how we will calculate. Water moving through a pipe. The velocity profile at some section is shown in figure 1.4 and is given mathematically u is equal to beta by, that is given u is equal to beta by 4 mu d square by 4 minus r square. So this thing is given. And v is the velocity of water at any position r, and beta is equal to a constant, and mu is the dynamic viscosity of water, d is the pipe diameter, r is the radial distance from the center line, this side central distance r. Not think about the this is radius. Okay, and what is the shear stress at the wall? Shear stress at the wall we try to know, and we will try to know due to the pipe due to the water, and what is the shear stress at the r is equal to d by 4. So at the r is equal to d by 4 you need to know, and if the profile persistent or length distance L along the pipe, what is the drag is induced on the pipe by water in the direction of flow over this distance. So here is velocity expression is given. So very easy, you need to calculate the du by dr, because in the direction of y we have the r, so that's why we'll calculate the du by dr. So we will get these things. Now very easily you can calculate the tau value, that is the dynamic viscosity, and your gradient. So very easily you can calculate. Hence we need to know r is equal to d, that is at the wall. Okay, r is the radial distance from the center line. So this is from the center line. Remember please, this is not from here. This is from center line. So this is whole, if we go from here to here, this is d by 2. So at the wall, this side also d by 2. So at the d by 2 at the wall you will calculate these things. If you will put r is equal to d by 2 in the velocity gradient, here is r is equal to d by 2, you will get the velocity gradient. I will multiply, definitely you will get. At the place of d, r is equal to d by 4, here you will put r is equal to d by 4, you will get the du by dr, then we multiply, you will multiply with the this formula, dynamic viscosity, you will get these things. So very easy. And how we'll calculate the drag? Drag is nothing but the shear force into area. So pi dl, because of the y pi dl we use, because in the length direction we'll move along the L, is question is given. In the question is given, we move along the pipe with the length L. So like that we'll get this answer. So overall the picture is that. So you please go through one by one, and thank you and best of luck for your final exam. So thank you all. So I think in November, I think in next month your final exam will be scheduled. So best of luck for your final exam. So today is the last class for fluid mechanics NPTEL 2024. There is a TA part. So hope you people enjoy the class. Let's conclude today. I'll conclude the class of TA. So thank you all. If anything, oh, thank you, thank you very much. Thank you. Okay, okay. Thank you, sir. Thank you.